All right, year 11. I've got this question here. Find the locus of the midpoints of the chords in the parabola x squared equals 4ay that pass through 0 and 2. Now, main thing here is the locus. Now, locus is an equation in terms of Cartesian equation, so which means the equation has x and y's only, not like p or q or any other terms. So we need to find the equation of the locus that involves the midpoint of the chords and the parabola, and which also pass through this point 0 and 2. Now, before we start, let's visualize this parabola to start with, not the locus, just the parabola. So that's a basic concave up parabola, and it's going through 2. So if I just do that, say that's a P, that's a Q. It can be anywhere, like could go this way, could go anywhere like that. But just I picked this two, that's all. Okay, and the midpoint of the chord is not the point 0 and 2. It can be anywhere here somewhere. I'm gonna put capital M. Capital M is for midpoint and a little m is for gradient. So we don't know what the coordinates are, but just visualize it. So that means that and that are the equal length because m is the midpoint, and that's the point that chords actually go through. Okay, now P, let's put some coordinates for P. The standard coordinates, 2AP, AP squared, and then here 2AQ, AQ squared. Okay, so that's done. I'll put the origin there. Okay, and this is the x squared equals 4ay. Have a habit of putting all the necessary features in the graphs. It's good to have that sort of habit. After we've done that, we need to go back and have a look. So this is what we're looking at. So the locus will pass through the midpoints and pass through 0 and 2. So somehow it's going to be, I'm just guessing that it could be, the locus might be a parabola. Then I'm thinking that's going through like this. So it's actually going through the 0.2 as maybe a vertex, and then passing through the midpoint. Maybe, I don't know yet. We don't know what it is, but I'm just guessing. So let's have a look to find the locus. Now we got all these points with in terms of P and Q. So eventually we need to get rid of them because the locus is always in terms of Cartesian equation form. So up to get rid of this P and Q terms, we need to have some special condition for it to replace it later on. So to find this special condition, we need to use the chord of PQ that pass through 2. So when I said special condition, it's most likely PQ equals something or APQ equals something. So I'm just going to put it here. We already know the equation of the chord PQ from previous lesson, so I'm just going to use it. I'm not going to show you how I got it. Maybe other lesson, I might post it. APQ equals 0. So that's the chord of PQ. And it's actually going through 0 and 2. So I'm going to substitute this into here. So it'll be 2 and 0 because x coordinate is 0, you times by 0, the whole thing will go 0. So plus APQ equals 0. And therefore, APQ is minus 2. So that's my special condition that I might need to use later on to find the Cartesian equation for the locus. So I'm going to leave that one up there for a second. And then another thing I need is a midpoint of PQ, the chord. So P and Q are the endpoints of the chord. So I can find the midpoint or equations, put it that way. So M, how do we find the midpoint? Just the average of the x coordinates and the y coordinates. So I'm just going to halve it. It says 2AP plus 2AQ, that's x coordinates, and then y coordinates, AP square plus AQ square. And I can sort of tidy it up a little bit. So that'll become 2AP plus Q, and then AP square plus Q square over 2. So I can cancel this one, and then I can make it into AP plus Q, and then this one I can't simplify any further, so I'll just leave it like that. Okay, so that's my midpoint on the chord PQ. Okay, so I'm going to use that. Now these ones, we can use it as parametric equations. Okay, so this is X and that's Y. So X equals AP plus Q, and then Y equals A over 2. I'm just going to write it like this. Okay, so we got two parametric equations, and our aim is to use these parametric equations to find locus, which is in terms of x and y's Cartesian equation. Eventually, guys, always, not 100%, sometimes it's this one, but most likely this will be your locus. Okay, so this need to be turned into Cartesian equation. Now we cannot say this is Cartesian equation. Why? Because we have a p's and q's, so we need to get rid of that or replace it with x term, something here. Now I can see something is very similar here, like it's got a p squared plus q squared, and then this one has a p plus q. So I'm just gonna make it into in terms of p plus q, so x over a. So I'm gonna something like this, I'm just gonna use it later, so I'm gonna leave it like this, and then I have to sort of use this to make it in terms of p plus q. Now important thing here to remember is p plus q square is not the same as p squared plus q squared. So please remember that. So you cannot just square it and substitute in there. You can't do that. So I'm going to show you how we're going to replace it, this p squared plus q squared, in terms of p plus q. So p plus q, if we do actually square it and expand this, you will get something like this. Now this looks pretty close, very close. It just got an extra term in there. So if we can get rid of this extra term, we can actually use this for this. So what am I going to do is, therefore, I can say p plus q squared minus 2pq will be exactly the same as p squared plus q squared. Do you get it? Yeah? Because the whole thing was this, and I'm just taking this one out, which is this, and then left with this. And now I can put that in there. So let's have a look. Y equals now a over 2, big brackets. Instead of a p squared plus q squared, I'm going to replace it with this. Okay, that way we can use p plus q, which is in terms of x over a. So I'm going to put that in there. So it would be, oh, maybe I'll change the color. P plus q squared minus 2pq. Okay, that's what I did. I just replaced this with this. That's all that I've done, nothing special. And then I can say now, instead of a p plus q squared here, I can actually change that into the x term here. So I'm going to put x over a squared minus 2pq. I can't use this one yet because I know we did at the start of the question, APQ, I'm going to write it here so I won't forget. We have to use something here, but here we have APQ, but this one only got 2PQ. But have a look at it, this guys. The first front of the equation, we already got A there. So if we expand this, we will somehow get an APQ. So I'm just going to leave it because I know it'll come up. So I'm going to leave it like that for the time being. Now this, I'm going to square it, 2PQ. And then I'm going to expand this, a 2 times x squared, a squared. That's the first one. I'm going to expand. And second one, minus a over 2 is a common factor, so it doesn't change. Okay, so I'm going to sort of cancel a's and then 2's. So I'm going to left with x squared over 2a minus APQ. That's what we've got so far. Now this is not a locus yet. Why? Because it's still got the PQ terms there. But soon it can be replaced it because the special condition we found at the start, we can actually use that now. So I'm going to move this one up a little. So let's have a look. I'm going to move it. Y equals x squared 2a minus 2 because APQ is actually minus 2. So y equals x squared 2a plus 2. Now this is a Cartesian equation already, but I would like to tie it up a little bit because since we study year 11, we do not use y equals x squared as a parabola standard form anymore. We use it x squared equals 4ay. So I'm going to put it in a sort of looking like this rather than just leaving it like this. So I'm going to make the x squared the subject. So I'm going to move this plus 2 equals y because I know my subject should be on my left hand side. So I'm going to move this one to this here. So it'll be x squared equals y minus 2. And then I'm going to times by 2a on both sides. So on my left, I only got x squared. That's what I wanted because I want to make the x squared the subject. And then I'm going to times 2a onto here. Can you see there's a similar to that? Yeah, there's an a there, 2a, there's a 4a there, and then that is that. Now this is sort of like a vertex form of parabola. So this is parabola, is a parabola with vertex at, that's a 0 here, coordinate is a 2. That's what we got. Okay, so the locus is parabola with a vertex 0 and 2. So I'm going to go back to the diagram that I started with here. So this is our vertex 0 and 2. Okay, so I'm going to draw a little parabola going through that, and then it has to go through the midpoint. So that's our locus there. That's our locus right there. The vertex is 0 and 2 and go through the midpoint of the chord.